If you clicked on this video, there's a chance that you've spent some money on a set of cylinder heads for your hot rod before. But have you ever had the opportunity to go behind the scenes and see exactly how a nice set of heads is made? Today, we've partnered up with Trick Flow Specialties to show you exactly that on a set of big block Mopar heads that we brought in for our custom 483 cubic inch stroker motor that we're building for Scanner Danner. We'll also have some discussion from Josh at Engine Rehab on how these heads fit our specific application later on, so be sure to hit that like button and enjoy the show. We want to give a big shout out to Trick Flow for not only sponsoring our build, but taking the time to shoot us some awesome behind the scenes footage to get a sense of how their products are made. Trick Flow castings are sourced from US foundries and come into their facility in the raw form shown. From there, the castings are fixtured into their Makino CNC machine where they will go through a proprietary machining process which includes machining the final intake and exhaust manifold surfaces, the valve cover rail surfaces, seat and guide bores, and the initial deck surface. With all of the initial features machined into the castings, the heads are deburred by hand to clean up any sharp edges and ensure smooth cast to machined surface transitions. Adam here is a machinist at Trick Flow, and despite how effortless and easy he makes this look, Trick Flow did clarify that he is indeed not a robot and instead developed these skills through months of training and practice. At this point, heads are also stamped with a date code, serial number, and a unique operator identifier for process traceability. Before the heads move on to any additional machining process, they're given a comprehensive multi-point inspection on a coordinate measuring machine to ensure that all critical dimensions are within tolerance. This is conducted periodically throughout each production run. Valve seats are 100% inspected to ensure that they're fully seated in the counterbores when installed, and verified again just prior to CNC porting. The deck surface is also filed to ensure that there are no burrs that will prevent it from fully seating on the fixturing in the machine for the CNC porting. All Trick Flow port designs are developed on the flow bench, digitized, and programmed in-house. Their DMG Mori machining centers are extremely accurate and precise, capable of repeating port dimensions to within a few thousandths. These are some of the nicest machines in the industry. During development, initial CNC ported samples are flow tested to ensure they match the original development ports, and heads are dyno tested to ensure they meet their performance requirements. Trick Flow is continuously re-evaluating their CNC porting programs to improve toolpaths and transitions, machine surface quality, and efficiency. In addition, after the porting is complete, cylinder heads are 100% pressure tested to ensure that there are no hidden casting defects and that water jackets are air and water/oil tight. In addition to machining the ports, this process also includes CNC chamber profiling, rough profiling the valve seats, and valve guide sizing. After porting is complete, the valve guides are 100% inspected for correct tolerance with a bore gauge, as well as checked with a gauge pin to ensure that they're straight. Trick Flow cuts their valve jobs on new and Contour CNC valve seat machines. All of their seat profiles are developed and optimized on the flow bench in conjunction with their port designs, valve profiles, and chambers for an intended bore size range. They typically employ a multi-angle intake profile, such as the 5-angle seat on the big block Mopar heads that we're using, and a radiused exhaust profile. The new in-seat machines offer single-point CNC cutting technology, which boasts limitless seat profiles without the need for custom tooling, improved chamber and bowl blending capability, and exceptional concentricity and machining quality for excellent valve sealing. Of course, no assumptions are made at Trick Flow, and the seat runout is inspected regularly. Prior to the final decking of the cylinder heads, each batch has the chambers CC'd to verify how much material needs to be removed from the deck in order to hit the specified chamber volume. With all of the machine work completed, heads and components are all solvent rinsed, washed, and QA inspected prior to final assembly. The final inspection also includes verification of various paint marker stamps, which are indications that all in-process QA checks were completed. Heads are assembled in batches of 4, with each step of the process running down the line before moving to the next step. The valves are lubed with Royal Purple Assembly lubricant and installed. And I'm just going to take a wild guess here that Jamie, one of the cylinder head technicians, might be a Beatles fan. Installed height is checked on every single valve before installing any required shims and spring seats. It should be noted that this is where accurate machining earlier in the process pays off, as with accurate machining, they know that all of their valve seats and spring pockets are at the correct depths, and it makes things much easier going together. Jamie works quickly, but we should note how careful he is to keep track of every single component as he works. The valve stem seals are lubed and seals installed using a sleeve to prevent seal damage and a simple yet effective bar to push them into place. A pneumatic spring compressor is used to carefully install all of the valve springs, retainers, and keepers, and finally, each head gets a final wipe down and visual inspection prior to packing. All Trick Flow cylinder heads are dyno proven to perform during the development process. This particular engine shown here is a 505 cubic inch big block Mopar running their 240 heads and single plane 4150 intake, and was recently on the dyno to validate the baseline for a different combination that's currently in development. They also conduct rigorous durability testing consisting of a minimum of 40 hours of load and RPM cycling that includes full blueprinting of all components before, during, and after testing to ensure all components, valves, and guides don't exhibit any signs of premature wear or failure. While the first portion of this video today covers the specifics of the 240 PowerPort CNC cylinder heads that we're using in our particular big block Mopar build, it's safe to say that this level of quality and dedication is representative of and can be expected of any product coming out of the Trick Flow factory. We're extremely thankful for the opportunity to work with them on this build and showcase their process to our viewers, so be sure to check them out and keep them in mind for any of your future engine projects. With that, let's get back into our shop for some more discussion on how these heads fit into our exact application.
Looks like you bought the heads I told you to buy.
I did. Well, actually, Trick Flow sent these out to us.
Okay.
Decided to be a sponsor on the build.
Okay.
But I guess today, these are PowerPort 240 heads that we're using on our big block Mopar build. Just kind of walk us through a little bit of what you look for in a set of heads. Obviously, here in my shop, we work on a lot of old stuff, and I mean, almost every head we do is over 20 years old. We don't get in a lot of brand new stuff. So what should somebody really look for to know if they have a nice set of heads?
All right. So I guess the best place to start is, are they easily available? Can I get them? Can I have them tomorrow? I've used these heads before. They're readily available off of Summit Racing. I had a very great experience with them. Any questions that I had, I was able to pick up the phone and get a good answer from somebody at Trick Flow, and that's honestly what I look for in a good set of heads is, do the people behind the product know exactly what they're putting out into the public's hands, and can they help me achieve what I'm trying to achieve? So for this Mopar build, we're doing a square setup, 4 1/4 inch bore, 4 1/4 inch stroke. You're not really left with a whole lot of options for a Mopar. You've got a lot of stuff at the entry level, and then beyond that, you've got a lot of really expensive cylinder heads and nothing really in the middle. For under $3,000, this is a phenomenal set of heads. And my experience has been, you can really take these things and drop them on right out of the box, and for 90% of the applications out there, it's gonna work great. So I already blew one of these heads apart, and I'm really having a hard time finding something to really criticize, especially for a high production application. And they don't treat it like it's a high production deal. We had some conversations with some guys on the production line at Trick Flow, and in my opinion, at the end of the day, what really matters when it comes to product quality is, do the guys that are working on it actually care? There's plenty of companies that have the best equipment out there, but it's really up to the operator.
Sure. So you mentioned you have to know what you're trying to achieve. What are we going to do as far as setting these up for our build, and why are these a good fit?
I wanted a head that we could just drop on, not do any porting to, not have to do a valve job on. If anything, we'd just do some very minor touch-ups, just little modifications to fit our application and to match the product we're trying to put out there, which really is just a sweet hot rod for some dude that just wants to make noise around town.
These are all CNC ported, CNC chambers. The seats are finished on a single point CNC seat machine. Really some of the nicest equipment in the industry.
Oh yeah. Oh yeah. I would give away my left leg to own one of those machines.
In your opinion, what is the most important thing on the set of heads?
That's absolutely the guide work. If your guide work sucks, your heads are going to suck.
And that's something that if people have watched my channel, they know that I talk about the guide being the foundation of the valve job. And there are a lot of shops that kind of do some shoddy guide work. So I guess we should start there and kind of go out. As far as our checks, we'll start there and kind of go down the line.
Yeah.
First thing anybody who's ever worked on cylinder heads is going to do as far as checking guides is just giving it the wiggle test. So give it a little wiggle, and the whole desk here is kind of moving, but exhaust guide there.
Any best guesses? I might be better at that than you are.
You're definitely probably better at guessing this because I like to use my gauge. I don't usually usually when I get a head in and I'm checking it, the whole valve goes like this because it's so loose by the time it gets to me. But they feel pretty, kind of tight to what I'm used to. So I'm gonna guess under 2000s clearance for sure.
Sweet. What do you go for on an iron guide?
I mean, on our John Deere stuff, we're 2.5 probably to 3 sometimes.
Sure.
That's what the spec usually calls for. We're definitely never under, we're never around 1.5 thousandths. I know that for sure.
Let's check this out. Oh yeah. I think I'm gonna call that 1.4, 1.5. Sounds about right to me.
The more scientific way to check, which is what any machine shop should be doing, is kind of a combination of the two checks, is with a dial bore gauge. So obviously people at home are not going to have a $500 dial bore gauge and a micrometer, but here in the machine shop we do. I'll just run that up and kind of get a measurement and lock it down. And then we'll set our dial bore gauge here. It's kind of a finesse thing to rock this back and forth right. I think right there we're zeroed pretty good. So now we'll go in here and actually measure. Kind of 1.4 to 1.5.
Looks pretty rad to me.
I think that's a good spot to be at on the intakes here.
That's perfect. That's in fact even perfect on the exhaust.
All right. Yeah, let's just go ahead and see what the exhausts are at. Yeah, looks like they are sized to about 1.4, 1.5 again.
Okay. That's exactly where I would have set it.
So what I like to see there on top of the clearance is they're nice and straight. We didn't have any taper throughout there. Now that we know our guides are sized where we want them and everything checks out there, the next thing we could maybe do is put a runout gauge on the seats and see how the seat work is. So I got a valve guide pilot that fits absolutely perfect in these guides. I mean, to the point where it's a little bit difficult to get in, but that's exactly how I would want the pilot to fit if I was machining these on our Surdy. I've also got the runout gauge here, and the way this works is we have the pilot down in the valve guide, and we'll get this gauge set up. Okay, so this little finger here is contacting almost the top side of the actual seat angle on the valve seat. And we'll just spin this here. And as this pointer spins around the valve, it's essentially raising the indicator up and down depending on how the runout is. And I have a little bit of parallax here, but I mean, that's like under a 0.5 thousandth, wouldn't you say?
That looks like a 0.5 thou to me. What's your limit?
I try to do as best as I possibly can, and I'm very happy if every single seat on a head was under 1 thou runout. Every once in a while you get some that start to push up 2, maybe more, but that's usually kind of a operator error when you don't have the right size pilot, or just trying to move too quickly, and there are things that you can avoid. But on a form tool machine like my Surdy, it's quite a bit more difficult than on a CNC single point type machine to get really nice runout like this.
This is quite different than a tractor, isn't it?
It's definitely very different than a tractor. We're shooting for a higher level of perfection here. Not to say that we don't shoot for a high level of perfection on our tractors too, but
The generic rule of thumb for valve seat runout is you can have as much valve seat runout as you have guide clearance. There's some other factors, but generally that's going to be the case. So in this case, we've got essentially 1.5 thou of guide clearance. So technically we could push it out to 1.5 thou. We're about, a couple 10,000ths up to 5 10,000ths. That's more than enough. That's a phenomenal valve job.
yeah, I've had brand new heads come in, like when we order some of our diesel replacement heads for the heavy duty stuff. I think I had one a while back that had 8 thousandths run out on a seat, on like a 1.5 inch diameter seat, which is just ridiculous.
I've heard horror stories of guys taking heads and bolting them on right out of the box, and then popping the head of a valve off because it's got so much seat run out.
Exactly.
That would be a bad day.
Let's adjust this out for the intake seat. Let's just put it this way. I would not put these on my Surdy because I'm not confident that I could improve this valve job.
I agree with you. If I do a valve job and I'm at a 0.5 thou run out, I'd be tickled.
I just adjusted this pointer out so that it's contacting the intake seat here. And this isn't perfect because my pilot can move a little bit up and down. But, it really doesn't get much better than this.
So, safe to say we're not going to be cutting these seats?
I am not going to cut these seats.
Neither am I.
I would run these as is. I think I would enjoy cutting these with how well this pilot fits in the guide. It's just a nice, snug fit. I know that they would cut nice on my Surdy, but I might achieve the same or slightly worse than what these are.
Have you ever cut the seats on a Trick Flow head before?
I have not.
They're ductile iron. They cut like butter. It's a great material.
Yeah.
I've been moving away from powdered metal seats, which a lot of the industry uses, and that's a wonderful seat. But the ductile iron cuts great, and it has a lot of compatibility with a lot of different materials. You can even run titanium on a ductile iron seat if you wanted to. But they cut very nice. What do you think about the surface finish?
I think it looks really nice, but again, we're going to go off of something a little bit more scientific than just looks. Let's put our profilometer on here.
I don't have one of these. Finger test is going to say low teens, even below.
So we're running a Cometic MLS gasket, and their spec, like if you read the box, it'll tell you, I think, under 50 RA is their recommendation for what you need to run their gasket, which 50 RA is, pretty up there. You should be able to easily achieve that on a good non-worn out surfacing machine. So let's just run this here, and then we'll run it on the block too and see what that looks like. So the profilometer there, that little stylus is running across the surface there and picking up every little dip and peak that's on that surface. And then they'll do a bunch of scientific calculations that we don't know how to do. 7.6 RA.
I couldn't do that. That's pretty good.
I don't think my machine will do that.
Nice.
I'm happy on my machine if I'm under 20.
The number I shoot for is, if I'm just doing a regular old surface, that's for a regular old engine, I'm going to spit out an 18 to a 24, and I'll be very happy.
Great.
I I think the best I can do is a 14 if the head's really, really nice.
Single digits, that's pretty impressive. I'm happy with that.
Yeah, that's quite good.
Let's check the block just for fun.
Okay.
Okay. So the block is not clean yet, but it's clean enough to toss this up here and do a test. I think I showed this in the video when I decked it, but now I don't remember. You can set the profilometer so it doesn't take as long of a measurement, but I like to just be a little patient and let it run and take a pretty long measurement. $18.
18.
I'm happy with that.
That's a great finish.
So
half of that on the cylinder heads. This thing's gonna seal up just fine.
yeah, that'll be nice. So I kind of handed the heads back over to you because you have a flow bench. You're kind of known as being a porting guy. You know what you're doing there, I assume. That's why I brought you out.
I know what I'm doing sometimes.
More so than me, obviously.
Sure. Yeah, I grind on heads every single day. It's kind of interesting because the port placement is very similar to the stock big block Mopar head. In fact, I think I want to grab the stock head and just put them side by side. Yeah, this is kind of cool.
Okay.
I just noticed that big fat crack there. Okay, let's move on. Let's ignore
These are the
that.
heads that were on it when it came in as a 413.
Wow. That chamber is kind of a nightmare. This is a lot more efficient. The big bathtub chamber is going to promote detonation. And this is a very, very modern heart-shaped chamber. Very easy to tune, very, very, very good on the engine, very efficient, and plays very nice with the way air is going to enter the chamber and overall engine efficiency, especially since here we're not building a 400 horsepower hot rod motor in a garage. We're building something that's going to be highly efficient and hopefully blow them out of the water. You know, I really want this thing to perform well. Now, in terms of porting, the number one thing we're going to get here is we're not having to work off of the factory casting. There's actually material added in on the aftermarket head that wouldn't exist on the stock Mopar head. And in the exhaust ports, if you get a shot looking down this exhaust port, you're going to see it's a great big ledge, and there's no short turn height. And the short turn refers to the transitioning area beyond the valve job, which is here, going into the bottom of the exhaust port, or going into the bottom of the port. And this is very abrupt. It's not really great for airflow. Now, on the aftermarket cylinder head, they've added some material up here, so it's not such an abrupt turn, and air is actually getting a real opportunity to make it around this corner, and it's actually going to flow properly. Air only likes to turn about 15 degrees at a time. If you try to ask it to do anything beyond that, it's not going to work. And this great big radius, I'm very happy with that.
So where did you learn this? Is this just from experimenting with your flow bench, or is this something you were taught?
It started off with me wanting to go hot rodding and not having any money.
Okay.
So it started off as a hobby, then realizing, hey, I really enjoy this. It's really fun to experiment and learn and understand how things work. And eventually that turned into a job, and I was able to find a place in the industry and actually work out a pretty good niche for myself. And it's been a pretty big obsession for easily the past 10 years. I think I ported my first head when I was 14 or 15. Okay. Very fascinating, very nerdy, but very, very fascinating. I just stuck my fat fingers down this intake port, and same thing, the short turn height is non-existent on the stock head. And it's actually quite amazing to me because these things make really good power stock for stock compared to the other brands. And before we start the Mopar versus everybody conversation, let's go take a look at this intake port on the Trick Flow head and see this big difference. So get a shot down there. Now you can see there's all this distance. That's easily an inch from the 45 of the valve job to the top of that short turn.
Okay.
That's huge power there. And then, might be a touch hard to see. We can't even see the other side of the intake port looking down the valve seat, and there's really no turn here. The short turn height here is easily about 3/4 of an inch, so maybe even less than that. And then the top of the radius happens way in the back of the port. Not very good for airflow, and to improve on that, you'd have to go larger on the valve. So another thing I'm seeing here is the valve stem diameter changed from the stock head to the aftermarket cylinder head. The stock Mopar stem diameter is 3/8, and that's fine relative to the application, but 3/8 valves are kind of irrelevant these days, and it tends to get really heavy. So outside of the scope of a stock or just a mild hot rod application, we wouldn't be using the 3/8 valve. Now on the Trick Flow, they did exactly what I would have done, and they put an 11/32 valve into these heads. And that does a phenomenal job of lightening up the valve train. And these, with modern priorities, valve train lightness and rigidity is a very, very high priority. Oh, check that out. That is not a cheap valve guide. I was wondering about that.
Oh, they're CHE?
Yeah. So we have CHE lifter bushings in the block, and I'm sure you guys have seen the other videos in the Mopar series. If you haven't, go check them out. There's a really good lifter bushing video, and those lifter bushings came from CHE Precision. That's not a cheap guide. That's almost like a $14 or $15 valve guide.
Yeah.
Whereas an iron valve guide is maybe what, $1.50, $2.
So I get a set of guides for what you can get.
Their slogan, last I remember, their slogan was, "Quality isn't cheap, it's priceless."
Yeah.
So
Yeah.
that's a very good sign that they're putting the CHE guides into these heads, especially for a set of heads that Joe Schmo will be able to buy. That's a good sign. They're very tough.
So what's the hardest part about working on old Mopar heads if, say, we wanted to rebuild these for our build instead of...
Probably fitting a spring pack into it. So we dug out some of the old valves, and our aftermarket heads use quite a bit longer of a valve, and that means that we can actually fit a proper valve spring into it, especially since we've got almost 600 thousandths of valve lift. With these, we'd probably be limited to something like, I don't know, 520, 530, some dinky little cam. Let's just get this flipped over. Oh yeah, that's conveniently light.
I thought maybe you were going to say the best thing is that you can actually pick them up and not screw your back up.
That is very true. Oh, and another thing, these don't go to water.
Yeah.
You Mopar guys know exactly what I'm talking about. Every bolt hole on a stock Chrysler head, Mopar head, goes directly into the water jacket.
This is the nice...
Oh, the nice head?
This is the nice head, I think.
Yeah, the other cylinder head had this whole center exhaust port situation rotted away, probably from not sealing the exhaust studs properly. I'm sure Nick can put a picture maybe right here of what that looked like. So just speaking to the real estate, you can fit maybe, I think the installed height on the springs for a stock Mopar were like 1 inch 700 or some ridiculous height like that. And like a typical Chevy will be 1 inch 800 all the way up to 2 inch. And you can't cut the spring pockets down, and you can't go longer in the valve length. So you're kind of stuck working with the stock setup. Now on the aftermarket heads, they can reposition rocker stands, change valve lengths. They can do anything that they want, and because they have done that, we can set up all the way up to a 2-inch, 2-inch installed height. That leaves you with options for any kind of spring. We're going with a hydraulic roller for this. We've got a custom ground cam for that. And the hardware, I know that you can order these heads with a flat tappet all the way up to a solid roller spring pack, and they'll be able to accommodate anybody.
Major differences, you talked about the differences in the ports, the difference in the chamber there, difference on the top side as far as getting springs in them, and I guess kind of one of the other main differences we've got here between these two heads is the valve size.
Yeah, I actually don't know what the valve head diameter is on a Mopar, so let's see. 2-inch 80. Now, a rule of thumb is about half of your bore size is a good place to start, and we're at 4 1/4, so 2 1/8. So 2-inch 120 or 2-inch 125 would be a good place to start on an intake valve. These come right out of the box with a 2-inch 190 intake valve, and that's honestly perfect. I'm all about it. Very nice quality stainless intake. Let's go take a look at the exhaust. Look at that big tulip on the back of the exhaust valve. Does the stock Mopar have that? Can we focus? Nope, it does not have that big old tulip. So if you notice, this taper is quite aggressive coming out from the 45 into the back of the valve up into the valve stem. This aids airflow. So that's just a nice little detail. It'll help pick up some horsepower. I did put these valves right next to each other. Look at that margin on that stock Mopar valve, very thin. Interesting. These are visually larger by about 30 thousandths. So let's see. Do my eye micrometers work?
Where's your banana mic?
I ate my banana mic this morning. Oh, eye micrometers are not that far off. 1-inch 760 thereabouts.
And what was the other one?
I don't remember.
730.
Yeah,
Holy,
30
wow.
thousandths.
I think you can just throw all your banana mics away.
Nice.
Alrighty. And the increase on the valve size is why we had to notch the block in a previous video. From the planning stages of this engine, we knew that we were going to need to notch the bores to get us some valve clearance here. These heads are designed for 4320 minimum bore size, and we are just over 4250 on our bore. So depending on how much valve lift you have, the valves end up getting fairly close to the cylinder wall as you open them. So let's just open the intake there, and at this point you can see where do you think that's at relative to our max lift?
That is our max lift.
That's our max lift. Okay, so right there you can see there on the side that we have plenty of clearance. Maybe do the exhaust side now. And if you watch the video where I actually did the machine work on the block, you'll see that it was a little bit tighter before we started, but right here I think we have plenty of clearance there. We're not going to have any issues in terms of valves hitting the cylinder wall. Would you consider it deshrouding the valve? Do you think that'll help with flow?
Yeah, in this situation, since we're actually getting right up to that bore, it's going to help the air transition into the cylinder and not run right into basically a brick wall. I got to say that this is the stage where I stop feeling bad about the tremendous effort, because the vision actually starts to come together here, and we're going to give you a shot of just the notches themselves, and you'll see the finished machine work, and hopefully that'll get you excited about this project.
It is kind of a daunting task in the beginning to plan this thing out. You helped me a ton with that, because I had never gone this in depth with one before.
This is part of the game. Here everything is custom. The heads were about the only shelf part we were able to buy for this project. Everything else was sourced by multiple friends, and I got help too, and it's It's been a huge team project.
Yep. So before we wrap this up, let's talk a little bit about the valve springs that these heads came with from Trick Flow and the valve springs that we're using, based on our decisions that we made with our custom camshaft and kind of how we came up with what we are using here.
Okay. So the standard valve spring is just a regular old hydraulic roller, dual valve spring. It has a flat wire dampener. Very typical for most applications. And they even come with a chromoly retainer with a 10-degree taper, which I'm actually a big fan of because this is the kind of stuff that's going to hold up to the abuse that Joe Schmo will put it up to. In our case, we're going to be pulling these springs off. And the reason is that we've got a custom cam grind from Comp. It uses a special lobe called an LSG lobe. And there's a big emphasis on lightening up the valve train, and they actually do call out a very specific set of valve springs to match the cam lobes. One of the big things about these larger diameter valve springs is they can tend to be very heavy. Going to tried and true stuff like this is going to reduce the risk of failure significantly. But when you're doing a custom application, you're often going to change to totally different setup. And when everything's nicely curated, like ours, we're going to be going to components that are a lot more application specific. We're going to actually shrink down the valve spring diameter and the height, and what that's going to achieve for us is we're going to save, I think, over 60 grams off of the top of the valve train. That weight savings is going to do a really good job of keeping the whole valve train happy, and this engine will stay together for a very long time and perform like it should.
Okay.
So big block Mopars come with a 1.5 rocker ratio. We're actually going to a 1.6 rocker ratio. That was a decision that we made as part of our cam lobe choice. One of the things that will happen when you go up in rocker ratio is you're actually going to multiply the reciprocating weight of your components because you're opening the valve and the valve springs. You're moving the components with a lot more force, and the acceleration of the parts has to be kept under control. That becomes really difficult when you've got, say, 150 grams worth of moving components as opposed to 100. This is the factory valve spring, and then this is the valve spring that we're going to. Here, this is a 1.550 outside diameter on the valve spring. Now the new one we're going to, I think, comes in at 1.320. On top of that, we're going to a tool steel retainer from a chromoly, and you can see that the actual cross section of the retainer is a lot thinner than the chromoly. And there's about a 50% savings in just the retainer itself.
But that doesn't make it weaker?
That does not make it weaker. The tool steel will outlast this engine and many other rebuilds on this engine.
Awesome. Yeah. Your intuition is like, oh my gosh, that looks kind of wimpy compared to the spring that's on there from the factory. But
yeah, for years we would put a performance valve spring into cylinder heads, and oftentimes it would get larger in diameter. But the technology has gotten so good, especially in the past 15, 20 years, we're able to come up with the same or more valve spring in a much smaller package.
Awesome.
And believe it or not, this valve spring has almost 80 pounds more pressure per inch of compression compared to this valve spring. So this is actually a lot more valve spring than that, and we're about 60 grams lighter.
Awesome.
So here's the stock chromoly retainer. I think this came in at 32 grams, 31. And here's the chromoly. Okay, 16. Now, even the locks are twice as heavy. That's the 10-degree valve lock set that went with the factory retainer. These should be about 4 grams, 6 grams. Okay. And
this is not the most accurate scale.
It's all for reference only.
Yep.
Actually, you should have a for reference only sticker right here. This is a machine shop after all. And then the new valve locks are 3-4 grams. You're really speaking to the accuracy here.
Yeah.
1 or 2 grams for in this context is going to be just fine. Now these locks, I asked for a very, very specific lock. These came from Debbie Jackson at Precision Products Performance Center in North Carolina. Chances are, if it's a lock being sold in the open market, she's probably the one who made it. Last I heard, I think she has about 700 valve lock part numbers. She makes all different kinds of valve train products, so big shout out to her. She hooked us up with all different locks to help us figure out what we needed to do to make this work.
Yep.
Let's get a weight on the valve spring. What's that? 161 grams. Now on a valve spring, obviously some of this spring remains stationary, so basically you'll go for about 2/3 of the total weight, which on this valve spring is 144 grams. And then on this valve spring, this should have been about 100 grams. And then the 2/3 of this total weight would have been about 66 grams. So then you'll add your weight of the retainers and your locks, and then we'll end up with a total weight savings of 58 grams from the old spring to the new spring. Between the weight savings and the added spring rate, we're going to keep this valve train very happy, and it's going to prevent us from having any valve train failures with this combo.
We haven't really touched on the push rods.
Okay, so pay attention here. This is where it's going to get a little convoluted. This is very nerdy stuff. In terms of push rods, I'm going to have Nick order the largest, thickest push rods that we possibly can fit in here. And the reason for that is the way the rocker system works, and any rocker system on these pushrod V8 engines will work. So the weight of the push rods and the lifters matter a lot less than the weight of the springs and valves because the motion is a lot slower on this side of the rocker arm as opposed to this side of the rocker arm. And that's because of the rocker ratio. So if you're moving at, and I'm going to use just square generic numbers, if you're moving at 100 feet per second on the pushrod side, with that 1.6 multiplier, you're going to be moving at 100 feet per second times 1.6. So that speed becomes multiplied, and that then gets calculated with the weight of the reciprocating components, and then there's another formula that turns it into force and acceleration, and just needless to say, make it really stiff on the pushrod side, make it really light on the valve side, and you'll make for a very happy valve train, and you'll be able to keep hot rodding and not worry about having any failures, and you'll just get to enjoy your car and enjoy your engine.
Okay, so that kind of gives us a little bit of perspective about what goes into setting up our custom valve train on a custom engine as opposed to a regular old engine that you're getting off the shelf parts for. Not too bad for a guy I found on the side of the street.
Yeah, I was not too long ago, I was searching through your dumpster, and here I am.
So I think the key takeaway from today's video is that we didn't want to just build a cookie cutter stock engine with this. We wanted to go above and beyond, and this is what it takes to do a custom engine. It takes a lot of time, and it takes reaching out to your resources. I mean, we're here to help you guys as your machinists, as your engine builders, and on top of that, we lean on the professionals of the industry as well to make these types of things come together. And you put your trust in the experts, and things go well. Invest in quality components. That was the other thing on this build. I didn't want to try to save a buck and go with cheaper parts. I wanted this thing to have the nicest components possible, and that's where we're at. We have a really, really nice set of heads that I would be completely happy bolting on right out of the box. It just so happened that for our particular application, we did do a little bit of changes there on the valve springs, but other than that, we didn't have to do anything to these. and we don't plan to do anything more to them. But, this thing's starting to come together. I think we have pretty much all of our parts sourced, and machine work is getting wrapped up, and kind of just keep moving along, plugging along. Just take some time.